Hi, everyone. I'm Aarushi. I'm a software engineer. And for my whole professional life, I've been a software engineer of some kind, whether it's Android development, iOS development, backend engineering, cloud, you name it. The point being that I've never been a machine learning or data scientist kind of person. But as of late, basically since the start of ChatGPT, OpenAI, all of these things, open source models becoming increasingly popular as well as increasingly more accessible, I've delved quite deep into the world of generative AI. And from my point of view, generative AI and AI in general is going down the path of going beyond building just pure wrappers around an existing API or going beyond using external companies and their chatbots. And so basically bringing engineering into AI. And so that's what this talk will be about. Basically, AI engineering and what will it mean to be one in the world of generative AI. So let's get started with what is AI engineering? Right. So firstly, I'm sure in terms of use cases you've seen or you've built, one weekend, a lot of these different use cases like chatbots, summarization, planning, fraud detection, personal assistance of some kind, and some of the more interesting ones that I'm sure you're all hearing about around drug discovery, protein discovery. The point being that it's a lot more accessible to do some form of AI as opposed to it being something that requires building a model from scratch and having a heavy background in maths or machine learning, and collecting a lot of data and doing that whole life cycle. Instead, it's a lot more about taking a foundational model, one that's already been built either as a closed source or an open source like Llama 2, and then applying your engineering principles to that foundational model. And why I say engineering principles is because initially it sounds like building an AI powered application seems pretty relatively simple, right? You take a foundational model, you write some code around it, and suddenly you have an AI app. And that works for a while for small applications. But if you really want to scale, that's where your traditional engineering principles come into play. And that, in my opinion, is what AI engineering really is. And so when I talk about engineering principles, I kind of mean our traditional ones when we build a classic RESTful app or anything, but applying them in a very different way to different problems or to different solutions. And that's what I'll talk to you about next. So the way I see AI engineering playing out right now is this concept of kind of plug and play with building blocks. Each of these building blocks being one aspect of AI engineering. It involves all of the components to get something up and running, as well as the structure, which is the engineering aspect of it. So I'll briefly talk to you about each of these, and then we'll go a little bit more in depth and what the new AI engineer needs to be doing or needs the skill that they need to have or where they can focus their upskilling on. So first is prompting, right? Or the really buzzy word of prompt engineering. And beyond the hype of prompt engineering and what it is and whatever else you hear about, like how much money you can make as a prompt engineer, it's actually a very interesting area at the moment, and it's very heavily research driven. So it feels like almost every other week there's different ways of prompting. And I've just listed a couple of them, like chain of thought, the tree of thoughts, self-ask with search. These are kind of almost old now, but they're pretty solid. And we'll talk a little bit in depth later. And then next, building on the prompt engineering, comes the block of retrieval augmented generation, which is the next step up in terms of being able to include more niche knowledge or more proprietary knowledge to your existing foundational models. And it involves a couple of different components like vector databases, document parsing, searching, indexing, and so on. Now, once you've got your prompt engineering, your retrieval augmented generation in place, the kind of the more interesting or the real value of these AI-powered apps comes from the concept of tools, using tools chains to build kind of an autonomous agent. So tools are basically just API integrations Chains are reusable workflows, and agents are these bots that can reason and logic using your large language models, because these things are actually quite good at doing certain level of reasoning. And so those are kind of some of the newer ones. And then your traditional engineering concepts that I'm sure a lot of people are already familiar with around reliability, resiliency, right? So there's already, but it's about applying it in a different way. So when you talk about large language models and or any kind of generative AI powered application, the reliability and the resilience kind of changes the where you need to focus, right? So for example, first up is evaluation. So yeah, sure, there's the evaluating which large language model you want to use, but once you've even picked one, evaluating that it's actually doing the right thing. Is it hallucinating, fact checking on it? Is it behaving the way that you expect it to behave for your very specific use case? And then comes model drift, right? And that's kind of fits both into resiliency and reliability. With any kind of model, especially one that either you're not hosting yourself or it's not one that you've built, any kind of upgrade to these models can either uh, change them for the better, hopefully, or they can also change them for the worse. Especially for different use cases, you'll notice that model drift starts to become a real issue. And so, yeah, evaluating that, monitoring that, making sure that even with this like model drift, especially when it's in a negative way, that your overall application is resilient enough to handle that and doesn't completely, go off the rails with that. And that kind of ties into the concept of guardrails, which is a little bit more of a newer concept for large language models. And I'll tie that into the next couple of components. Then you have your monitoring and observability. Again, like all of your traditional monitoring, observability techniques and tools are still relevant, but I'm not going to touch on them. I want to touch on the newer things that opens up that you need to start monitoring and observing. So firstly, prompt tracing, right? So yeah, so you can start tracing your own human generated prompts quite easily, right? Whatever somebody, either you, an engineer, product manager, whoever is prompting. But then once you start introducing agents and autonomy into these applications, they start prompting themselves, right? So that thing of like thinking to themselves. So you want to trace those prompts as well. That's probably where the most value comes out of it, to know when and if things are going wrong and be able to explain why potentially an output came the way that it did. And then again, continuously monitoring your model drift as well. Maybe you have some kind of metric set up in terms of what you consider a good or a bad output. And you could start alerting on that based on, and that would be you monitoring your model drift. Then output tracing, and then continuously evaluating that your model is behaving as it should be. Basically, it's behaving the way that you originally thought when you first evaluated the large language model. And then scaling, obviously that's a huge concern in any kind of software application, but even so in generative AI applications. First being infrastructure, I think most people are probably aware of the kind of arms race going on in terms of GPU, and not just buying GPU, but also even renting it from GCP, AWS can often be either quite expensive or just not available. And then comes like the concept of like caching and managing costs. So firstly, inference is probably one of the most expensive things, especially if you are using an API. And even if you are using your own hosted models as well. And yeah, just how do you scale that? And then caching, right? So that's a um, pretty normal technique to scale your apps further, and it works within large language models as well to reduce that constant inference every single time. But caching introduces new problems in this LLM powered world, where now all of a sudden you're looking at doing semantic kind of caching and making sure that the algorithm or the logic that you're using kind of fits in better with the natural language. And then next comes safety and control. And this is kind of one of my favorite ones at the moment to really dive into. The second you start talking about any kind of autonomous agent, right, whether it's a chatbot, some kind of planning agent, some kind of personal assistant, whatever it is. You're suddenly letting go of the control from a human being to this artificial intelligence. And that includes that it automatically gives you a bunch of different problems to solve. So first being moderation. So I think everyone's aware of moderation in the traditional sense of toxic behavior, abusive behavior, criminal behavior, that kind of stuff. But with large language models, you can actually start getting very, very granular on what you consider needing to be moderated, as well as how you want your application or your bot to respond to certain moderatable events, right? Maybe you have a threshold that certain events are just a warning, certain events are a block, and certain events are straight up, we need to escalate to the top, to either law enforcement or something like that. And then going beyond moderation, one of the kind of both a curse and a blessing with large language models is the fact that they're trained on what's essentially the all of modern human knowledge. So that means they can talk about anything, and often they're good at it, right? Often sometimes they're hallucinating, but the fact is that they're happy to talk about anything. And that can also include non-toxic, non-bad topics. But often in your case, whether it's like example, if you're building a chatbot, do you really want your chatbot going off topic and talking about how planes stay in the air? That's probably not the expertise that your company is in, or your application operates under. So being able to lock it down to not talk about certain topics or only stick to certain topics. Then jailbreaking. Obviously, there's always going to be malicious users, and when you allow a large language model not just to have access to a user, but also to have access to different other integrations within your either internally or to other systems, that obviously opens up security breaches and malicious users getting in some form. And so again, that's the concept of guardrails. And lastly is fine tuning. So the way I see AI engineering progressing is, rather than building a model from scratch, it's more about taking a foundational model and beyond retrieval augmented generation, going down the path of fine tuning. And again, so that it becomes, you've got the base of a model, and then you're just adding making it specific to your use case or specific to your knowledge or data set. And again, this is also a heavy area of research, and it's very, very interesting as well, right? So just a couple of the techniques that I've listed, but it feels like techniques come out every other week here as well. So the classic reinforcement learning with human feedback, low rank adaptation, prompt tuning, and so on and so forth. And we'll go into a little bit later. Okay, so let's go into a little bit of each of these and so the structure that I'm going to follow now is what it is, what the current state is, and what do you as an AI engineer need to be doing, or what an AI engineer should be focusing on in this space. All right, so we talked about prompt engineering. As I mentioned, a couple of the existing ones around chain of thought, tree of thought, self-ask, react, which is reason and action. And these are all forms of sophisticated prompt engineering. And again, there's a big research community around it. Lots of research and theory comes out regularly. So what does it mean for the AI engineer then? Well, firstly, the way I see it is it's important to keep up with these research papers. And to be honest, they're also all very, very interesting, and more often than not, very digestible and readable. So why wouldn't you? And then keeping up with these research papers means that you should be trying to implement wherever you can. Obviously, it's not always going to be possible, but a lot of the times it is, right? So for example, chain of thought, tree of thought, self-ask with search, react. And lastly, keeping up with open source and just the general community in general is going to be very, very important. For example, LangChain, because what you'll find is that more often than not, somebody in the community is working on something to implement a research paper that you're reading, and you can work off of their work, or you can provide help as well and contribute in some form to these libraries or different frameworks like LangChain. Next is retrieval augmented generation. So I won't go too in from the technical point of view on what retrieval augmented generation is, but at a high level, it's a way to do a couple of different things, right? One is to provide very niche knowledge, up-to-date knowledge or data, attempt to reduce hallucination, um, and involves a couple of different things. So basically what it is you take a vector database, and these vector databases have existed for a while, but the newer ones are very veered towards these new use cases about plugging into different large language models like OpenAI, Llama Index, or one of the many ones that you can find on Hugging Face. Um, and it involves taking all of your data, whether that's structured, unstructured, probably most likely in natural language, creating an embedding out of it, which is just numbers to how a computer can understand your natural language, putting it in the database, creating an index so that it's searchable and it's fast to search. And then when a query comes in from either a bot or from a user searching the database, and whatever you pull out of that database, you would pull out X amount of data or documents, putting those in the context to the large language model. So suddenly it has access to whatever information or knowledge you wanted to give it, right? So in this world, you can already see, right, there's a couple of different things that we're talking about. So what does an AI engineer need to be doing then? First is vector database evaluation. So there's so many out there at the moment, and there's trade-offs with all of them, as well as pros. And as an AI engineer, it's going to be up to you to figure out which one works for your particular use case, right? So maybe you need a database that's fully open source so that you can host it yourself, you can make whatever changes that you need. Or maybe you care more about one that abstracts away all of the hosting and managing, and you want just a managed one, but you want it to be super customizable and super configurable so you can choose the data structures that it uses in under the hood, or the similarity algorithms that it uses, anything like that. Then chunking and indexing decisions, right? So whenever you're taking all of your data and creating these chunks, there's always a trade-off on the size of the chunk that you're going to turn into numbers, and making those decisions for your particular use case, as well as indexing decisions, like I mentioned, of like what kind of data structure, what kind of algorithm to search through the index. And then lastly, thirdly, I mean, I don't think that you would need to really implement any kind of these like similarity metrics, but it's important to be able to understand them so that you can pick and choose what works for you. Deploying databases, maybe, and then large language model and an embedding model evaluation, right? Whether you're going open source or closed source, there's so many of both types and both very relevant. And again, and you'll probably notice this is a theme, but keeping up with open source as well. And they can be basically your guidance and where you learn a lot of information from at the moment. Okay, and so next, the thing that I want to talk about was tools, chains, and agents. So tools are just your access to the outside world, really, right? It can be an API, they could be a Google Doc, they could be a database, and anything else that you can think of that you can programmatically access. Chains are groups of functions, so basically a reusable workflow that you know the agent needs to have access to regularly do. And then agents, which is, I think, the most interesting kind of topic at the moment in this space, are independent, self-directed bots that can think for themselves and make decisions, and they can come in different types as well. So what does an AI engineer need to do in this space then? Well, firstly, I think it's about going beyond being just purely an engineer, and it becomes more about working very, very closely with the business and the product. Because this space is so new, it's really driven by engineers or by people who really understand AI on what you can do with it, or how you can improve existing workflows, or how you can create new products. Secondly, your traditional kind of software engineering, writing your API integrations, whether that's using some kind of framework like LangChain or building your own. Then monitoring and observability, some of the things that I talked about earlier. Managing costs, this is a big one. So if you're talking about doing an autonomous agent, it's very easy to just rack up an insane amount of money basically for this. So how do you manage those costs? How do you monitor those costs? How do you ensure that your bot isn't eating up resources? Testing, how do you test this kind of stuff, right? Traditional unit testing probably won't be the only option here. And then again, keeping up with open source because and the general community, because that's where a lot of the innovation is happening. So for example, two of my favorite ones are LangChain and Llama Index as frameworks. And then going into reliability and resiliency a little bit. So we talked about the traditional and the new kind of concepts of reliability and resiliency around caching, evaluation, model drift, that kind of thing. But what does an AI engineer need to be doing in this space? So basically, firstly, it's a little bit of R&D or trial and error on where resiliency is weakest. So there's not really like a golden solution at the moment with a lot of these large language model powered applications, and it just kind of depends on figuring out for your use case where things are going wrong or where the potential to go wrong with things is. So a lot of like experimentation and being a little bit playful with this kind of stuff. Working on caching with large language models, choosing your cache, choosing your caching strategies. Latency, that's a big one to be thinking about as well, both if you're using an API or whether you're inferring directly. Thinking about and building out guardrails, and we'll talk about that a little bit more in depth later. And then lastly is the last of the kind of the traditional ones, observability and monitoring. All right, so again, we talked about kind of traditional and new, but the new ones around prompt tracing, model drift, and continuous evaluation. Again, this kind of becomes a little bit of a trial and error on what needs to be monitored, where you see weaknesses, where you feel you don't have the visibility. And this can also often be something that you need to work with the business side of things on what, not just the engineering visibility, but what kind of business visibility do we need as well. And then again, costs, figuring out how you're going to observe these costs, figuring out how does the model change over time, and not just model drift, but also with the data that you're collecting on different users or different use cases, how you're fine tuning or how this large language model is learning on the fly as users interact. And then a little bit of R&D on how do you monitor as well, because again, this space is changing so heavily. Within 2 or 3 weeks, suddenly as something newer or something better comes out. So it's really important to keep up with that and keep being a little bit more playful on that side. And then scaling. So I mentioned like GPUs, costs, latency, plus all of your other traditional scaling needs. And so in my opinion, the concept of GPUs and figuring that out shouldn't really come under the responsibility of an artificial intelligence engineer. I think it should be, the abstraction should be one layer up. And so in my opinion, what an AI engineer needs to do then in terms of scaling. So this is more around scaling or with like monitoring, cost analysis, caching, continuous R&D, and keeping up with the open source world to see how you scale out these kind of large language model apps, how you keep your, how you scale out your vector databases, and how you keep the cost down there as well. And then safety and control. So this was one of the ones that I mentioned that I really like, and I think this is a very interesting space. So as we talked about, right, moderation, staying on topic, jailbreaking, and guardrails. So what does an AI engineer need to do in this space? So firstly, and I think one of the most important things is because it's so customizable and you can go very granular with this space, it's important to work with the other members, and not just engineering, but with your PMs maybe you have a safety team, maybe you have a law enforcement team, maybe you have your customer service and operations team, and to work out and build out your use cases for these guardrails. All right, even for moderation, what do you want to moderate? How do you want to moderate? What level? What granularity? And then topical. Which topics are you comfortable with your app talking about? Which ones do you want to change? And then, yeah, so customizing to your needs. And then obviously the next one is build and monitor these guardrails. And then you'll be using open source libraries. The one that I use is from NVIDIA Nemo. And then continuously improving on this, because you'll find that no matter what kind of guardrails you come up with, over time you'll find either they don't work or they do work, but users find a different way around these guardrails, and you're going to continuously update and improve these so-called rules. And finally is fine tuning. So like I mentioned, I think the space of AI engineering means more about taking an existing model and changing it to your needs. And so what does the AI engineer need to do in this space? First is your traditional data engineering concepts, right? Collecting your data, cleaning your data, formatting your data set. Then is, again, keeping up with these research papers and making sure you're up to date on all of the latest things that are coming out, because they're the ones where you find more optimized ways of fine-tuning, or even being able to try different fine-tuning techniques for your particular use cases. And then experimenting. So I think, again, it's a lot of like experimentation and playfulness to figure out what works, because there's not 100% like a one solution fits all kind of situation at the moment. And then finally, actually building the thing. Yeah, so let's just, as a recap, what AI engineering will mean in the world of generative AI. So AI engineering is AI plus our traditional engineering principles, but applied slightly differently. So kind of same, but kind of different. And some of the ones that we talked about is retrieval augmented generation, prompting, agents, reliability, monitoring, scaling, safety and control, and fine-tuning. Yeah, so thank you for that. If anyone has any questions, please leave them in the chat, or I've left my LinkedIn as well. Yes, I can share the PowerPoint, Adrian. Andre, thanks for the talk. You mentioned NVIDIA and Nemo. Cool. Yeah, so that's an open source library. It's still very much in its alpha phases, but I think it's worth starting to look into and maybe even adopting with care. And it's basically based off of NVIDIA's language Golang, which is natural language to define certain rules and flows for what your large language model can actually do. And what it can't do. And it works basically with any kind of large language model plus an embedding model for those rules. I can send you a link to the repository at some point, but it's very cool. It's very powerful. Yeah. Any curated lists or sites you recommend for staying up to date? Yeah, so the two of the ones I would follow is TLDR AI. That's a newsletter. I would also follow LangChain's Twitter page or LinkedIn, whatever. Llama Index, two very good ones. And generally the blog posts that Hugging Face put out as well. They're very up to date. So I would follow those. For a more comprehensive list, I can put something together if you message me after.